when you create an Instagram account, how does Instagram actually remember your name? Or if you exit this YouTube video right now at 10 seconds or 5 seconds and you come back to it, how does YouTube understand you already watch 5 seconds or 10 seconds or 20 seconds and understands where to continue? Or let's say next time you log into Netflix, how does Netflix actually remember what movie you watched yesterday? So the answer to all of these questions is a database. So what is a database? In this video, we would understand what is a database, what a database is being used for, and we would understand the different types of databases that are most used on a day-to-day basis by cloud and DevOps engineers, and when to use which database over which one. So the appropriate definition of a database is just an organized collection of data that is being stored. So in our previous videos, we've been talking about front end, back end, and how we as clients trying to access applications and how the traffic flows. If we had to recall that, remember, everybody on this side of this image is a client. It could be a smartwatch, a tablet, Android phone, iPhone. It doesn't matter, your PC, your MacBook. When you are trying to connect to any application such as YouTube, that you are on YouTube right now, right? So your request goes to a YouTube server and you get a YouTube page sent back. But if you, because you are watching this video from the web server, it goes to the YouTube application server. It says, hey, you're trying to watch a video that was uploaded by Tech by Yannick, and the logic behind your routes, and sends you back now to a back-end database, which is where YouTube stored or would store this video the minute I upload this video to YouTube. So this is the process that most applications work. But if every application, especially enterprise application, would have a database in the back end. And the way the database works, it is responsible for four main things. And let's understand using an analogy. So a database can be used to store information. So YouTube would definitely store this video that I upload to YouTube in YouTube's database. So it's also used to retrieve data. So you, the user who's trying to watch this video, let's say you come back to YouTube and you make a search on YouTube. Let me just write what I'm talking about here. So it is used to store data. It is used to retrieve data, right? Like by you, when you come to YouTube and you want to watch this video, you search and you hit play. So it goes to the database, fetches this video, and basically sends back the video to you in a user-friendly interface on your screen, right? So it's also used to update data. A database updates data. So in the sense that I have this video on YouTube, I could decide tomorrow I want to delete, I want to change the title of the video. I want to change, I want to crop the video or modify the video. I would do it on my end, hit save, and when I hit save on my computer, YouTube updates this video or what I do to the file in the back end of the database. And the last thing that a database would be important or necessary for us to do would be to delete information, right? So let's say I no longer want this video to be on YouTube for whatever reason. I could delete the video, right? And this video would be deleted in the back end of our database. So there is four main types of databases that are being used by DevOps engineers on a day-to-day basis. And we are going to cover all four types of databases. So the first database being used a lot by DevOps engineers on a day-to-day basis is non-relational databases. So non-relational databases are being used by DevOps engineers a lot. So, let's start with relational databases. So relational databases are being used by DevOps and cloud engineers a lot. And this is basically a database. I would use the analogy of a bank, right? Let's say you work in a bank, right? And management wanted you to create data or an employee table that would show all basically a database that would store all of the information about the employees in the bank, such as the employee IDs, the departments they work for, if they are in the credit card department, their emails, their logins, and all of that stuff. So what a developer would typically do is he would store that table. He would store that data in tables. He would create multiple tables, and in the tables, he would use rows and columns. Between the rows and columns, he would have rows for or columns for employees' IDs and employee names. So we could have one table, right, where this is for employees' IDs and employees' names. We could have another, he could create another table where it has like the departments and then the department IDs, right? Right? And then employee ID, right? And then he could create another table, right? Where he has employee name, right? And probably employee department. So all of these tables are related. They are related because they all contain information that are related to each other. And because this information is related, every time we try to query it and it's similar, we would have to go for a relational database. We use relational databases when we are trying to store information that is related across different other multiple pieces of information that we need to query. Examples of relational databases would be Postgres or MySQL databases. The second type of databases being used a lot are non-relational databases. Non-relational DBs. So non-relational DBs are being used to store information that are not related. Just like here, say employees information that are related. So non-related information, that would be information such as, let's say we have an e-commerce application, right? Or an e-commerce store. And we are trying to store files or like dynamic. It basically we store non-relational info that is ever changing. Let's say key value pairs, for example, right? In our e-commerce applications, or like let's say files for that are being used to route logic, and these files are ever changing and very non-consistent data. In that case, we would go for a non-relational database to store these. Examples of non-relational databases, here we would have non-relational databases. Examples, we will have MongoDB. We have MongoDB, and we have, let me see. Yeah, just leave it here. I wanted you to see MongoDB. MongoDB and DynamoDB. These are both managed databases, right? So the third type of databases being used by DevOps engineers a lot on a day-to-day basis, right, would be, one second. So the third would be in-memory databases. So this one is very important. I would explain this using an example. So let's say you log into an e-commerce application, right? And you add an item to your cart. If you notice, let's say Amazon, or it could be any e-commerce application that's using, what's this back-end system again? Shopify. Yeah, a lot of these companies use. So let's say it's an e-commerce application, any store on Shopify, for example. Whenever you add something to your cart, you come back after a day, 2 days, a month, sometimes even up to 3 months, right? And you still see that item on your cart. Now the question is, how does that store or that application knows that you added something to your cart? That information was stored in an in-memory database. So an in-memory database is basically optimized to actually remember what you stored. So whenever you log into that application, so the e-commerce application is definitely in the back end, right? So there is an in-memory database here. And whenever you log in to that application, so the logic in the back end checks to see the state when you last logged in, and whatever you save or stored with your login is definitely being showed to you, like, okay, you added the card, you are being seen it. So the fourth type of database, which is very commonly used by DevOps engineers and cloud engineers, would be a time series database. So with a time series database, this one is being used when you are dealing with data that is being related to, like, timestamps or time series, just like we said, time series, like you are dealing with metrics, for example. Let's say you want to know that let's say you want to know at 10:00:05 CPU was 42%, right? And then 10, let's say 08 06, your CPU was 48%, right? So it stores the data basically. What's this percentage sign? I don't care. So okay, percent. So it stores your data basically in time series. So this database is basically being used when you are trying to let's say we are setting up monitoring and observability, if you know anything about the advanced DevOps concepts. So this is when, oh, by the way, I did not give you guys examples for the memory database, in-memory database. I'm sorry. So examples of in-memory databases, we have Redis, Memcache, and Valkey. Those are examples of in-memory databases, right? So for the time series database, like I said, examples in this situation, we have InfluxDB, and we have Prometheus. Prometheus is an observability database. Prometheus. Okay. Yeah. So basically, these are the 4 types of databases that are being used by DevOps engineers on a day-to-day basis, and these databases are being optimized for different things, just like you can clearly see. So we have a relational database, is basically optimized for the relationships between different tables. So this is being used. We would go for a relational database when we are trying to store data that would be related between the different tables. We go for non-relational databases when non-relational databases are being optimized for speed. So in a sense that they have to be fast because they store value in key value pairs. They store data in key value pairs, and this data is ever changing. So it has to be. Now, if you thought non-relational databases are fast, imagine what how fast an in-memory database would be. So with in-memory databases, they are really, really super fast. If a relational DB is able to query an information in milliseconds, an in-memory database would be able to query that information in nanoseconds. And think about it. That's why you are able, and the reason is because it stores that information in the RAM. By the way, with relational databases, the way it stores information that's advanced. Let me not get into it. Yeah. So it's this one, it stores the information in memory, it stores the information in your RAM, making it very fast. And with a time series database, it stores information in time series, and it's being used a lot for like when you are trying to get metrics. So this could not only be, it doesn't only have to be monitoring. It could be, let's say you are setting metrics like metrics such as KPIs for management front office. You're setting KPIs for the sales team or KPIs for finance, and you needed a database. You would definitely be going for an InfluxDB or a database that would allow you to store that data within time series. Now, within these 4 databases that are being used on a day-to-day basis, let's say you as a DevOps engineer, on top of here, we have a relational database. Let me not confuse you guys. I mean, you guys know what I'm talking about. So the first is relational DB, non-relational, in-memory, and time series DB. So if management or your team came up to you and said they needed a database, the question is, how do you set up any of them? Or let's say you guys agreed, the developers needed a database from you, a DevOps engineer, and you guys agreed you would set up a relational database. How do you create it? That would be our question now. So the way you would have multiple options. So in order to create, let's say you decided you wanted to create a Postgres DB. Let me write it. Oh, Sorry, guys. Let's say you wanted to create Postgres, right? If you wanted to create Postgres or MySQL, you would have three options. So the first option would be you could go buy, we talked about servers, right? You could go buy a hardware server, right? Which is what we call on-prem. So you would go buy a hardware server. Oh, where's these arrows, right? So you would buy a server, right? And on top of the hardware server, what you would do is you would install your Postgres DB. And once you install your Postgres DB, you could put the server in a data center, you would configure it, and you will install all of your Postgres DB. Or you could go to a cloud provider such as Amazon, such as AWS or GCP, or such as Google Cloud or Azure, right? You could go to them and say, hey, give me, you could say, give me servers. You want virtual servers from them, right? Which is what we call VMs. You could go to them and request for virtual servers. And now on top of the virtual servers, you yourself would have to install a Postgres database. But on this one, you buy the server yourself, right? And you install it. You go to Amazon, right? Or AWS, sorry, Amazon, Azure, GCP, right? And you actually get the servers and then you install it. Oh, this, okay, okay. And then you have a third option. So what is your third option? Your third option is, so mind you, remember, yeah, you only got the infrastructure from the cloud provider. So yeah, you could go still to any of them, AWS, Amazon, or GCP, and instead of just getting a virtual server, you could get a managed Postgres instance. So what it means is, you just click, you do a couple of clicks on your screen, such as like go to Amazon, right? You do a couple clicks, you go, I want a Postgres, and you just click, 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 and they give you a Postgres, right? It could be any of them. Now they charge you, it's managed. They charge you per how often you use it. They charge you per managed Postgres or managed SQL, managed MySQL. So when they give it to you, because it's managed, they take care of updates, they take care of patches, they take care of security, right? So, and it's easy. You don't have to install it, you don't have to configure it, it's easy. So now the question would be, what option should you choose? This would depend on your company. Now, let's say you go and buy these servers and go to a data center and start installing. The question is, why would you even do that? They still do it today. And the time when this is done is, let's say you worked in a bank, right? And in the bank, you are dealing with a lot of critical applications that you don't want these servers to be elsewhere. You don't trust the security. I mean, they are trusted to an extent, but your applications and the files you are dealing with are so critical that you don't want to just let AWS, Azure, or GCP, or any cloud provider fully have access over the physical servers where those application files reside. So that is when, as a bank, you would actually build your own data center and install everything and get a whole lot of engineers and people to manage the data center, right? But let's say the application files you are hosting are non-critical. Let's say you are not a banking company. Let's say you are, let's say, an e-commerce company, but the data you are hosting in the database is payment systems, let's say payment information, even though it's encrypted, but compliance requires you to still have them stored in some type of server, right? That is when you would actually use a cloud instance because it's non-critical and you could use it. And this let's say, because right here, remember, in this second option, you are only getting the infrastructure. Once you get the infrastructure, you install MySQL on it. And right here, you are still responsible for all the patches and updates to that instance and to your Postgres server that is installed on this computer or on this server. Now with a Postgres server, or with a managed Postgres or managed MySQL server, what happens is Amazon or Azure or GCP, whoever the cloud provider it is that you definitely got this managed server, managed database server, Postgres or MySQL. Whoever this cloud provider is, they would be responsible for actually patching and actually updating and maintaining your server. For example, let's say the Postgres you got was V2. They would be responsible for helping you with upgrade to V3. So that's the difference with all of these three. So guys, we will definitely go more in depth into the different types of databases. The main reason I talked about this is that as we go on, and even if you are not on my channel and you are just on YouTube, and I make these videos because when I actually started, there were not a lot of videos online explaining little things like this. I got into classes back in the day and people just ran with stuff. I myself, I had to go around the internet and go research things and learn them. But in my opinion, I just think that you should understand this before you start hearing all the complex technologies that we would be talking about. They are not complex. Guys, DevOps is not even that hard. The thing is, if you skip this part and then you jump into a class and someone starts talking about, oh, set up a MongoDB, set up a MySQL DB, you don't even know why. And in modern DevOps, 2026 DevOps, if you are still studying just because you want to understand tools and you don't know the why of stuffs, I hate to break it to you, you might never really break this field because there is a lot. And the best way to go about it is to understand the why of things. It's not every tool you have to study. There are some tools that you really have to study, and there are some you really just have to understand what they do. And you might even work for 5-6 years without ever touching them. Guys, there's things that I studied and I worked for years without ever using them. But I've gone to interviews and I've had to talk about those technologies because you have to understand them. But now you go get hired by a company and you almost never use these technologies, and then you lose your job or you need a career change or something. And so guys, there's a structure. Just get the fundamentals. This is not a video for me to understand like how to learn DevOps. I know I took it a little bit offhand. Stick to the program, and in our next class we will definitely start talking about virtualization and cloud, physical servers, virtual servers. That is where we would be heading towards in our next future videos. And I would also start a series on interviews, how to interview, career change, how to break into DevOps. And guys, a lot of amazing videos coming through. Stay tuned. And if you did not understand any part in this video, that's why it's a video. You could go back or put a comment with anything you didn't understand, and I'll respond to the comment explaining exactly in an easy way that you could get it. Thank you and stay tuned.